Welcome. This video is about operating system structures. Operating systems are the fundamental software that manages computer hardware and provides services for applications. Understanding the structure of an operating system helps in comprehending how it works internally. In this video, we will explore the core components, services, and system calls that make up a modern operating system. Let us explore the core components of an operating system. First, process management. It creates, schedules, and terminates processes. It also handles process synchronization, communication, and manages deadlocks. Process management ensures fair central processing, unit allocation among competing processes. Second, memory management. It allocates and deallocates memory space as needed. It tracks memory usage and implements virtual memory systems. It ensures memory protection between processes. Third, file system management. It creates and deletes files and directories. It manages file storage, organization, and retrieval. It implements file access controls and permissions. Fourth, input-output system management. It controls all input-output devices. It provides device drivers and buffering mechanisms. It manages data transfer between devices and memory. Now, let's delve into additional operating system components. First, protection system. It ensures controlled access to system resources. It implements authentication and authorization mechanisms. It prevents unauthorized access to memory, files, and hardware. Second, networking. It manages network connections and protocols. It implements network security and packet routing. It provides application programming interfaces for network communication between applications. Third, command interpreter. It provides interface for users to interact with the operating system. It interprets and executes user commands. Examples include command prompt on Windows and Bash on Unix or Linux. Fourth, kernel. It is the core of the operating system that loads first. It manages hardware resources directly. It provides low-level services to the rest of the operating system and applications. Let's discuss the operating system services provided to users and applications. First, file management. It involves creating, deleting, and manipulating files and directories. It provides access control and file permissions. It supports various file operations like read, write, and append. Second, process control. It includes creating and terminating processes. It also includes suspending and resuming execution. It manages process priorities and scheduling. It provides mechanisms for process synchronization. Third, input-output operations. It manages input-output devices. It provides buffering data between devices and memory. It handles device errors and interrupts. It also provides device-independent interfaces. Fourth, security. It provides user authentication and authorization. It controls resource access and protection against unauthorized access. It also detects and prevents malicious activities. Fifth, resource allocation. It allocates central processing unit time, memory, and input-output devices. It manages resource conflicts and prevents deadlocks. It also ensures fair distribution of resources among processes. Sixth, accounting. It tracks resource usage by users and collects statistics on system performance. It monitors system activities and provides usage reports for analysis. Here are some additional operating system services. First, error detection and handling. It detects hardware and software errors and taking appropriate corrective actions. These include hardware errors in central processing unit, memory, and input-output devices. Software errors, such as invalid operations and memory access, are also handled. It uses recovery mechanisms and fault tolerance. Second, communication services. These facilitate information exchange between processes running on the same or different systems and involve shared memory mechanisms, message passing interfaces, and network communication protocols. Third, program execution. It loads programs into memory and executes them, handling program termination normally or abnormally. This involves memory allocation for program code and data, central processing unit scheduling and context switching, and program initialization and cleanup. Fourth, system utilities. It provides utility programs that help in system maintenance and management. This includes file management utilities, status information and monitoring tools, performance optimization utilities, and system configuration tools. Let's learn about system calls. System calls provide an interface between a running program and the operating system. They allow user programs to request services from the operating system kernel. System calls are the only entry points into the kernel from user programs, ensuring controlled access to hardware resources. They provide a programming interface to operating system services and are typically written in high-level languages like C or C++. They are hidden from programmers by the application programming interface, and they transition from user mode to kernel mode during execution. Here is a diagram which shows the different layers starting from user applications, followed by application programming interface libraries, then the system call interface, and finally the operating system kernel. Let's see the common categories of system calls provided by modern operating systems. First, file management, which includes operations for creating, deleting, opening, closing, reading, and writing files. It also includes operations for managing directories. Examples include open, close, read, write, make directory, remove directory. Second, process control. It includes operations for creating, terminating, loading, and executing processes. It also includes waiting for events and signaling between processes. Examples include fork, execute, exit, wait, kill. Third, memory management. It includes operations for allocating and freeing memory. It also includes operations for memory mapping and protection. Examples include memory allocate, free, memory map, break. Fourth, device management. It includes operations for requesting and releasing devices. It also includes operations for reading from and writing to devices. Examples include input-output control, read, write, select. Fifth, information maintenance. It includes operations for getting and setting system information. It also includes operations for getting time and date. Examples include get process identification, get user identification, time system information. Sixth, communication. It includes operations for creating and managing communication channels and includes network sockets and inter-process communication. Examples include socket, connect, send, receive, pipe. Let's explore how system calls work. System calls are implemented through a specific mechanism that allows transition from user mode to kernel mode. First, the application calls a function from the application programming interface library. Second, the application programming interface library sets up the system call by placing parameters in registers or on the stack. Third, the application programming interface executes a special instruction, like trap or software interrupt, to switch to kernel mode. Fourth, the kernel executes the system call handler. Fifth, the kernel returns the result to the application programming interface library. Sixth, the application programming interface returns the result to the application. This mechanism ensures controlled access to privileged operations while maintaining system security and stability. Here is an example of user program calling the open system call in C. The open function opens the file using the open system call. There is an error message if the file cannot be opened. Finally, the close function closes the file using the close system call. Let's see the detailed flow of a system call from user application to kernel and back. First, the application calls a library function. For example, open or read. Second, the library function prepares system call parameters and executes a trap instruction. Third, the system call interface identifies the requested system call and validates parameters. Fourth, the kernel executes the system call and prepares return values. Fifth, control returns to user space with results. Sixth, the library function returns results to the application. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.